So for a long time, we thought we had a pretty good handle on storms. We figured our predictions were getting better and better. But it turns out, a shocking new discovery shows we've been dangerously underestimating the threat. And it changes, well, pretty much everything we thought we knew about the future of extreme weather.
I mean, think about it. Those sudden, just violent downpours that turn streets into rivers in minutes. It feels like something out of a disaster movie, right? Well, that's becoming our new reality. Today, we're going to dig into why that kind of storm, the kind that used to be a once-in-a-lifetime event, is happening with terrifying frequency.
You probably remember Hurricane Harvey. It dumped an entire year's worth of rain on Houston. Just wrap your head around that. Or the floods that completely submerged the city of Jingzhou in China. These weren't just bad storms. They were events that completely shattered all expectations, far, far more extreme than our best climate models ever saw coming.
And that brings up this huge, kind of unsettling question. How could our best science, our most powerful computer models, get it so wrong? What crucial piece of the puzzle have we been missing this whole time?
Okay, so for decades, climate science has relied on this one simple classic formula. It's based on physics we've known for ages. A warmer atmosphere can hold more water vapor. The rule of thumb was, for every degree Celsius of warming, the air holds about 7% more moisture. It's a neat equation, and it predicted a gradual, somewhat manageable increase in rain. But reality had other plans.
The problem is, the real world has been kind of mocking this old rule. The superstorms we're actually seeing are blowing those predictions completely out of the water. This was a huge red flag for scientists. It told them that something much bigger was at play here. Something critical was missing from the equation.
So, a team of scientists decided it was time to just scrap the old tools. They realized if they were ever going to understand these new storms, they needed a completely new way of looking at them. And what they did was incredibly ambitious. They essentially upgraded our planet's climate model from standard definition to stunning HD. See, the old model saw the world in these big, blurry 100-kilometer chunks, way too big to see individual storms. The new model zooms right in, viewing the world in a super sharp 10-kilometer grid.
The difference is staggering. It's literally like switching from an old fuzzy tube TV to a brand new 8K screen. Suddenly, what was just a blurry, pixelated blob of clouds sharpens into this highly organized army of individual thunderstorms, each with its own incredible dynamics.
And here's the kicker. It worked. When they ran past storms through this new HD model, it simulated their intensity with pinpoint accuracy, something the old models just consistently failed to do. For the very first time, they could finally see the true face of these modern superstorms.
So what was this hidden force? What was lurking in those high-definition details that the old blurry models had completely missed all this time? Well, the answer is a total game-changer for understanding flood risk. It turns out the problem isn't just that the atmosphere is holding more water, like a bigger bucket. The real culprit is the storm itself.
You heard me right. The storms themselves have evolved. They've become these powerful, super water-sucking machines. In a warmer world, they're better organized, more structured, and way more efficient at pulling in massive amounts of moisture from all around, and then just dumping it all in one spot.
Now, the scientific term is mesoscale moisture convergence. I know, it's a bit of a mouthful, but just think of it like this. It's the storm's engine. And this powerful process, this engine, where organized storms concentrate rainfall, it was practically invisible to the old low-res models. And this is the missing piece. It wasn't just about more fuel, the water vapor, for the storm. The engine itself has been supercharged by all the extra heat, allowing it to run faster and stronger than we ever thought possible. So this discovery led the research team to a staggering and, frankly, a pretty terrifying new forecast. They ran their HD model forward to the end of the century, and the number it came back with is a serious wake-up call.
By the end of this century, the most intense rainfall event of the year is now projected to be, on average, 41% stronger than it is today. Let that sink in for a second. 41% more intense.
And here's the most crucial part of their entire research. Of that 41% increase, only about 14% of it comes from the atmosphere holding more moisture. That's the part we already knew about. The other 27%, the majority of the increase, comes from that supercharged storm engine we just discovered.
This is why our past predictions were so dangerously optimistic. We were only seeing the tip of the threat. that 14% increase from moisture. We completely missed the massive, hidden danger of the 27% increase from the storm engine. We were underestimating the real danger by nearly a factor of 3. That's huge.
So let's bring this all down to earth. A 41% increase isn't just some number on a scientific paper. What does this new, wetter, more violent reality actually mean for our cities, our homes, and our lives?
Well, it means that a once-in-a-century flood could now happen every 5 to 10 years. It means those record-breaking floods could become the new normal. And it means our entire infrastructure, our drainage systems, our dams, our flood plans, they were all built for a climate that just doesn't exist anymore. They are now dangerously inadequate.
And let's be crystal clear, this isn't speculation. This is a stark warning from brand new research, peer-reviewed and published in the top-tier journal, Nature Geoscience. The evidence is in. This is the real deal.
You know, maybe the biggest takeaway is this simple truth. Nature doesn't follow a gentle script. We can't expect gradual, predictable changes anymore. We've unlocked this powerful feedback loop with this storm engine. The future of extreme weather isn't just a slightly worse version of today. It's fundamentally and dangerously different.
This incredible scientific leap has really given us a gift, a much clearer lens to see the future. The blurry, misleading picture has been replaced with a high-definition warning. The science has done its job. And that leaves us with one final urgent question. Now that we can see the true threat, are we prepared to act?